So here we're going to look at the algebra of the consumer choice problem. This time let's begin in graphical form. So here are our axes, the x-axis and the y-axis. We'll label it x and y. And then let's draw in the budget constraint. So there's the budget constraint, and let's label that. And now I would like to draw in a couple of indifference curves. The first one I draw, I will call U1. The second one I will call U2. So let's label the first one U1, the second one U2. U1 is the lower indifference curve. U2 is better, but none of the points on U2 are attainable, and the choice problem is to get to the highest indifference curve that's still consistent with the budget constraint. So now let's try to write that problem algebraically. We envision that all the points can be given a utility number, and the indifference curve all have a constant utility number. So we maximize the utility of x and y, subject to x and y is non-negative, and subject to the budget constraint. The budget constraint is the expenditure on x plus the expenditure on y, and I think I miswrote that as pxy. That should be pyy, is less than or equal to income. And we have it in inequality form at the moment, but if more is preferred to less, we can just assume the equality form of the budget constraint. And now let's write it as pyy rather than pxy. Expenditure on x plus the expenditure on y equals income. That's the budget constraint, and you can now view the consumer choice as a constrained maximization.